Hi students, welcome to physics classes. Today we are going to discuss about orbital velocity. What is mean by orbit? What is mean by orbit? Orbit is the path followed by the satellite. Path followed by the satellite is referred to as its orbit. This is the path. In this path, satellite will move around the earth. This path is referred to as its orbit. Now, orbital velocity. Orbital velocity. Orbital velocity of a satellite is the minimum velocity. Minimum velocity required to put the satellite into a given orbit around the earth. Means to move around the earth. What is the minimum velocity a satellite required? Minimum velocity a satellite required is orbital velocity. Orbital velocity. Now, the centripetal force required to keep the satellite in its orbit. Whenever the body is in circular motion, it will have centripetal force, that is F equal to mv square by r. Equation number 1. Now, according to Newton's law of gravitation, gravitational pull acting on the satellite, gravitational pull acting on the satellite is F equal to G capital M small m by r square. Gravitational force. Now here r means distance between center of the earth to satellite. Capital R means radius of the earth. H means height of the satellite above the surface of earth. Height of the satellite above the surface of earth. Now V is the required velocity. V is the required velocity. Small m is mass of the satellite. Capital M mass of the earth. G gravitational constant. Now from equation 1 and 2, as both are forces, if we equate 1 and 2, mv square by r equal to G capital M small m by r square. R gets cancelled in r square one time, r times. M small m gets cancelled. V square equal to gm by r. V equal to root gm by r. And acceleration due to gravity formula we know. Relation between capital G and small g. G equal to capital Gm by r square. Here r capital R refer to radius of the earth. So we can take r square to this side. Gm equal to G into r square. So if we substitute this value here, instead of Gm, if we substitute G r square, we will get this. V equal to G r square by small r. If this r square coming out of the root, we will get r into G divided by, here r means from center to satellite, small r. So from center r, radius of the earth r plus height h. R plus h. Now, if the satellite orbiting very close to the surface of earth, height above the surface of earth is much less than radius of the earth. Already we have r equal to r plus h. Then as the height is very less, it can be negligible, that is nearly equal to radius of the earth. V stands for orbital velocity. We can write V naught. V naught equal to, as the formula we have r into square root of G by r plus h changed as r. Then this r is coming inside becomes r square. R gets cancelled. Square root of gr. And we know g value 9.8 meter per second square. R value 6.4 into 10 power 6 meters. If you substitute in that formula, we will get V naught equal to 7.92 into 10 power 3 meter per seconds. 10 power 3 meters becomes kilometer. 7.92 kilometer per second. V naught, orbital velocity equal to 7.92 kilometer per second. And this value of orbital velocity is different for different orbits around the earth. It is different for different orbits around the earth. As we considered, h is much less than r. If we take a much height above the surface of earth, this can be considered. So we'll get different values. This is a minimum value. As orbit changes, this value also changes. And this value is independent on mass of the satellite. Here, as we got V naught equal to square root of gr, or we got V equal to gr square by r, or r into square root of g by r plus h. In all these, orbital velocity is independent on mass of the satellite. In all the formulas whatever we used, V equal to gm by r, square root of gm by r, or gr square by r into g by r plus h, square root of. Whatever these formulas, we didn't have mass of the satellite. So orbital velocity is independent on mass of the satellite. Whatever the mass we have, we won't depend on it. It depends on mass of the earth and height above the ground. Acceleration due to gravity. Okay. Thank you for watching. Please subscribe.